Hello guys, welcome back. So in this lecture, we are going to learn about a new sorting algorithm that is called quick sort. As you can see, this algorithm has a little bit catchy name because its name starts with quick, right? So you guys will imagine like it can sort quickly and eventually it does so. So let's try to understand its definition and then let's try to understand what it does, how it works, right? So we have a definition over here for quick sort. So it is a sorting technique that sequences a list by continuously dividing the list into two parts and moving the lower items to one side and the higher items to the other side. Okay. It starts by picking one item in the entire list to serve as a pivot point. The pivot point could be the first item or the randomly chosen item. Okay. So what is pivot item? Like what technique is it? You guys might be confused right now, right? So in simple words, let me explain you what it is. Okay. So let's say we have an array, right? We have an unsorted array. So what we do in quicksort is we pick a random element. Let's say you picked an element from the starting. That is, let's say you have an array of 1 to 10. Okay. And the first element is 5, let's say, for example. Okay. You pick that number, then what you will do? You will search in whole array which all number is smaller than 5. You move them to the right side or sorry left side, and then which all numbers are greater than 5, you move them to the left side. And same process we do for every single element in the array. It's simple as that. Okay, now let me show you one example. So for that I have to pick or let's create one array from 1 to 10, right, as I've said. So let's pick 5 as the first element, and then 5, and then let's say 3, and then 7, let's say 2, 1, okay, 9, and then 8, and then 4, and what else is left, guys? 5, 3, 2, 1, 6, okay, 5, 6, 7, 8, 9. Okay, so let's take this array. So how quick sort will work in this is, let's say we took the pivot point as this first number. Okay, we can take any number from the array as a pivot point. Okay, so pivot we took as 5. So what we will do, we will simply check all the elements which all element in the array is smaller than 5. So we have this one element which is smaller than 5, we have this element which is smaller than 5. Okay, so how we will collect it? We will collect all the numbers which are smaller than 5. Okay, so how it will work, just try to visualize it. Okay, so this number is smaller than 5. Okay, this number is greater than 5. Okay, and this number is again smaller than 5. So what we will do, we will switch their position, because we will keep all the smaller numbers, all the numbers which are smaller than 5 together, and the all the numbers which are greater than 5 together. Okay, and then we will swap the place of the pivot point. Okay, let me show you how it works. Okay, so this number is smaller than 5, but this number is greater than 5, right? 7. So what we'll do, we'll switch their places. So here instead of 7 we will place 2, and instead of 2 we will place 7. Okay, so this way we have two smaller numbers together and then greater number together. Okay, now again we will check another number. This number is also smaller than 5, but this number is smaller than 7, right? 7 is greater than 5, right? So what we will do, again we will swap their position, because we have to keep all these small numbers together. Okay, right? So we have all these small numbers together and then great numbers together. Okay, so now we will check. 9 is greater than 5, we will not do anything. 8 is greater than 5, we will not do anything. 4 is again greater than 5. 4 is again smaller than 5. So what we will do, we will simply swap this number here. Okay, and then this number here. Okay, so this way we have all these small numbers together, all the large numbers together. As you can see, last number is also greater than 5, so we will not do anything. Okay, so now how we have the arrays, we have this part, or you can say small array as this one. Okay, so the first half is this one, and then large array is this one. Okay, So what we will do finally, we will simply inject our pivot point in between the smaller array and then the larger array. So how it will look? It will look something like this. So here we have the smaller array and then we have the pivot point and then we have the larger array. Okay, it doesn't matter like the elements are sorted or not, even though these numbers are not sorted, but they are smaller than the pivot point which we have picked, right? So we will keep them in the left side and then the numbers which are greater than 5 we will keep them in the right side. Okay, and then what we'll do the same process for the left side and the right side over and over again. Okay, until we get all the elements sorted or in their correct position. Okay, so yeah, for this what we can do, we can take help of the recursion, right? Because recursion will be the best solution to implement this one. But implementation related thing we will discuss in the next lecture, don't worry. Here just try to understand how it works. Okay, so this was the first step and this thing will keep on repeating for each of the element. Okay, even if you get the sorted array in the first half and sorted array in the second half, then also see, from human eyes we can see, right? We can be sure like this array is sorted, we should not do, but the logic will not be sure, right? So what it will do, it will still keep on iterating through each element to make sure every element is in its correct position. So all the elements which are smaller than the pivot point should be in the left side and all the elements which are greater than the pivot point should be on the right side. It will we are going to check that same thing for every element in the array. Okay, then only at the end we will be sure like our array is totally sorted. And this is all about quicksort. This is how quicksort works. Okay, so this is how I can say like this is the best way possible which I tried to explain you the quicksort. Okay, because when I tried to learn it I got so confused because the one who taught me this was like he confused me a lot with this quicksort. So that's why I thought to explain you in the best way possible. Okay, so now let's try to visualize it in visual algo. Okay, the same thing we are going to do. Okay, so here we have visual algo and then we have quicksort selected and then we have some elements. So let me just quickly increase the speed. You guys can't see the what is the footer part of it, that but that doesn't matter. All that matters is we can see this sort button, right? And by now you are already aware of this visual algo, so I don't have to discuss that much, right? So we have this array. Let's see how quick sort works in it. Okay, so I hope it will start selecting the first element. It's going too fast, right? So for that I have to decrease the speed a little bit because I want you to visualize for the first iteration only. Okay, so let me just refresh it. Let me close it and then quick sort. Okay, so we can start, right? Okay, so we have our first element. Let me collapse these things, these are annoying. Okay, so we have our first element. Let's see how it goes. Okay, so here I wanted to tell you these purple elements, it is changing the color of these elements in purple because these elements are greater than 23. So greater elements will be in purple color in visual algo, right? So if it is a great purple color, that means that number is greater than our pivot point, right? Now as you can see, the number 8 was smaller than 23, right? And this 8 number was also smaller than 25. So what it does, it swapped their position because we want to keep all the smaller numbers together and all the larger numbers together. Okay, the way I have explained you in VS Code, right? So let's see how it goes. Okay, 15 is again smaller than 23, but it is also smaller than 50. So these two will, I think, swap their places, right? So right now we have smaller numbers together, larger numbers together. So far so good, right? So let's see. 23 again, 23 is equals to 23, but it is smaller than 41. So these two are going to swap their places because again we are going to keep all the small numbers together, large numbers together. Let's see. Okay, so 23 was equals to this, so it never swapped their places. So this we can say is an edge case, so that's fine. If it is equals to this, then we will not swap their places. Okay, so yeah, 7 was smaller than 23 and it was smaller than that number, so it have swapped their places. Okay, Now 14 is again smaller than 23, swapping happened. 28 is greater than 23, nothing will happen. So right now, as you can see, all the green numbers are smaller than 23. All the purple numbers are greater than 23. So what we are going to do, we are simply going to pull it from here and place it in place of 14, because that is going to be the correct place of this number, right? So this way, all the numbers which are in green will be on the left side, and all the numbers which are in purple will be on the right side. So let's see how it goes. Okay, so what simply happened, we simply swapped the last element position with the pivot point. That's it. Okay, and the same process we are going to repeat for this side and this side. Then only once the iteration is done for every element, we will be sure, or the algorithm will be sure, like all the elements are sorted. So let me quickly play it so you guys can see it. Okay, so orange means that number is semantic now. Okay, we are not going to touch that number. Okay, so let's see how it goes. Okay, so the same thing is going to happen over and over again for all the elements. Okay, so I don't think like I have to explain you over and over again the same thing, because it's just the same process it is doing for the different elements, right? So as you can see, so far these elements are semantic, these elements are sorted, so we are not going to touch those elements again. So whichever element is unsorted, we are going to touch those ones only, right? So let's see. Okay, so we have 3 elements left, and then I don't think there is much sorting left in this. Okay, so this way we get all the elements sorted in the array. Okay, so this is all about quick sort. What to say, this is all about we can say quick sort in terms of theory, right? In terms of understanding how it works. And I hope I made this clear, like how quick sort works in this video. So let's quickly try to implement quick sort right in the next lecture. So this is it for today. See you in the next one.